In this video, we're going to use TensorFlow namescopes to group graph nodes together in the TensorBoard web service so that your graph visualization is legible. First, we import TensorFlow as TF. Then we print out the version of TensorFlow we are using. We are using TensorFlow 1.8.0. The example we're going to create in this video is to add 4 named TensorFlow scalars together using the TensorFlow add operation. First, we'll add 2 scalars together using TensorFlow's add operation. Then we'll add another 2 scalars together. Finally, we'll add the 2 results. Let's get started with our first name scope. So we say with tf.name_scope. We're going to set the name to scalar_set_1 as scope. Now that we have the scope, let's define our first constant scalar. So we use 4 spaces, then we use the TensorFlow.constant, we give it the number 10, we give it the name of 10, and we assign it to the Python variable tf_constant_1. Next, we define our second scalar the same way. 4 spaces in front of the Python variable, we use TensorFlow.constant, we give it the value of 20, the name of 20, and we assign it to tf_constant2. And finally, we do our TensorFlow.add with TensorFlow constant 1, TensorFlow constant 2, and we give it the name scalar 10 plus 20. We assign that to the Python variable scalar_sum_1, again leaving 4 spaces. And note that we leave 4 spaces between the start of the line where our code is to make sure Python knows that we are still under the name scope code block. Next, let's hit return on an empty line to signal to Python that we are finished with this code block. Let's now print the Python variable tf_constant_1. We see that it's a TensorFlow tensor. We see that the name scope is scalar set1, which is what we defined up here. Then we see the variable name, which is 10. We can see that the shape is empty since it's a scalar, and we can see the data type is int32. And remember that TensorFlow first builds the graph and then later evaluates the graph. And since we're still in the building the graph stage, both of the TensorFlow constant scalars haven't been evaluated in a TensorFlow session yet, so they are still uninitialized. Next, let's define the second scope. So we say with tf.namescope, we're going to assign the name scalar_set_2, and we say as scope. Now that we have the scope, we define our third constant scalar. So TensorFlow.constant, we give it the value 30, we name it the string 30, and we assign it to the Python variable tf_constant3, again leaving 4 spaces in front. Next, we define our fourth constant scalar. So we use TensorFlow.constant, we give it the value of 40, the name is the string 40, and we assign it to the Python variable tf_constant4. And then finally, we do our second scalar addition. So TensorFlow.add tf_constant3 plus tf_constant4, and we give the name of the result as scalar30 plus 40, and we assign it to the Python variable scalar_sum2. Then we hit return on an empty line to signal to Python that we are finished with this second code block. Finally, let's create a final sum that adds the 2 scalar sums already done. So we do TensorFlow.add, and we have our scalar sum1 Python variable from the first name scope. Then we have our scalar sum2 from our second name scope, and then the result of this addition is going to be assigned to the Python variable scalar sum. Now that we've created our TensorFlow graph, it's time to run the computational graph. So we launch the graph in a session, then we initialize all the global variables in the graph. The next thing we want to do is send our TensorFlow graph to TensorBoard so that we can visualize the graph. The way we'll do this is to use TensorFlow's summary file writer to create a protocol buffer that serializes the structured data of our graphs so that TensorBoard can later create a visual representation. So we do TensorFlow.summary.filewriter. We're going to assign this to the directory graphs. We want to pass in our session graph, and we are assigning the file writer to the tf TensorBoard writer Python variable. Now that we're done with our computation, let's close the file writer. Let's also close the TensorFlow session to release the TensorFlow resources we used within the session. Next, let's close Python so we can start TensorBoard from the command line. First, let's check to see if there's anything in the graphs directory. We see one event protobuf that we just created. Now we can use the TensorBoard command line utility to specify our log there and have it start the TensorBoard web service for us. So again, we're in the graphs directory and we're going to start the TensorBoard service. You can see that we're using TensorBoard. The version is 1.8.0 and it's going to host the service at this web address. Because I am on a Mac, I'm going to use localhost. So I type in localhost:6006. And we can see TensorBoard loaded. you can see our two namescopes. We have scalar set 1 and scalar set 2. And this is why TensorFlow namescopes are extremely useful when you build larger graphs, because by using name scoping definitions and operations, we were able to group graph nodes together to make it easier to see what was going on. Let's first click in the scalar set 1 namescope. Move it back so we can see it. And when we do that, inside we can see our graph of 10 plus 20 and our operation of the addition. And you can see that when I hover over where it goes to this addition. So we can double click and close it. Then we can click into the scalar set 2 namescope and we see our other two nodes. So 30 and 40 go into the scalar addition operation, and that then later feeds into this add operation. So you can see the arrow goes into the add operation, and we double click on the namescope to close it. Perfect. We were able to use TensorFlow namescopes to group graph nodes together in the TensorBoard web service so that our graph visualization is legible.